We have the 2017 arithmetic paper today. It's pretty similar to the previous ones. Now let's get going with it. Writing that first number, why don't you do the first 3 questions as before. That third one is a little trickier than the usual division that we have in this paper. You can give it a go. I think I'll pause the recording for those watching at home. You can pause the video, work those 3 out, and then press play for the explanations. All right, so for the first one, just be careful here. Remember it says 8,000, not 80. So 308, like that, 1,000. So we're going to need a comma. Whoopsie. I'm expanding it. And then 520, so 520. A couple of kids have put a space after the comma when typing this. You don't need a space there, it just goes right in between the numbers. Okay, second one should be nice and easy. I'll do it on the board just so you can compare how you've done it, see if you've made any mistakes. So 825 minus 573, 5 minus 3 is 2, borrow from this 8, give the 1, you get 5 and 2. So the answer is 252 for the second one. Now the third one, some of you may prefer to do this with long division, but if you only know how to do short division, which I'll show you, then don't worry, you'll be able to do it that way as well. So 23 into 2, first of all, 0. 23 into 20, you can join those up because we didn't use the 2. 23 into 20, another 0. And then you can carry the 20 to the 4. So this is using the short division method. So now we need to do 23s into 204. So obviously, well, I would assume most of you don't know your 23 times table. So what we can do is use what we already know. So we know 23 times 1, 23 times 2, hopefully, is 46. Those are going to be way too low. So let's go up to 23 times 10. Okay, sorry about that. So we need to go up to 23 times 10, which we should know is 230. So that's too high, but 204 isn't far off. So you'll figure out now, I'd say 23 times 9. So you can either do that with a little bit of multiplication over to the side, or you can take away 23 from 230 to get your answer. So can anyone give me 23 times 9? What did we get there? Did you write it down? Yeah, 207. 207, still a little bit too high. It's just 3 higher than it should be. So 23 times 8 should definitely go into 204. I'll put 8 there, I remember. But we need to figure out what 23 times 8 is so that we know what our remainder is. So let's do a little multiplication. 184. So 23 times 8 is 184. See how I'm making notes on the side here systematically so that I don't waste any of my time by having to work things out again. I can keep track of what I'm doing. So we know that 23 times 8 is 184. We needed it to go into 204. So the difference between 184 and 204 is 20. So we carry 20 to the 7. Now 23s into 207, we already worked that out. One of the bonuses of having our working written out nicely. So that goes in 9 times. So our answer to that question is 89. Perhaps if you found that tricky, just try and do some more division with large numbers. You can use a calculator to check your answers, and maybe you can write a remainder where necessary. So do some double-digit numbers into 1,000 numbers. Okay, now number 4, someone had asked if this could be done with the numbers as decimals. It would be possible with a lot of fractions, but because we have 1/3 here, 1/3 as a decimal is 3 recurring. So when you're doing column multiplication, you can't do 5.3333333 and going on forever times the other number. So we do have to do these as fractions. Now, hang on, I'm going to put these on a new page so I have some more room. So you have 5 1/3 times 3 3/4. Now, multiplying fractions, I need to convert those into improper fractions. So can someone tell me what 5 1/3 would be as an improper fraction? And then I'll get 3 3/4. No, sorry, I've lost my notes. But 16/4, that 16/4 is 4, so that's not going to work. Yep, 16/3, I think some of you mean. So we do 5 times 3 is 15, plus 1 is 16, that's our numerator, and then it's thirds. You're just asking how many thirds you have in 5 1/3 when you convert it into an improper fraction. And for the next one, you're going to do 3 times 4, 12 plus the 3. Yep, several of you have given me that answer. That would be 15/4. Now, when you're multiplying fractions, what you can do is just multiply the numerators, multiply the denominators, and then simplify your answer. That will give you the right answer, but it's a little more complex than it needs to be. So what I'm going to do is see if we can simplify the fractions before we multiply. Now, we can't simplify vertically, but remember with fractions, we are allowed to simplify diagonally is what I mean, diagonally when we're multiplying. So if these numbers will cancel out, then I can do that. And if these numbers will cancel out, then I can simplify that way. So as long as I've got a numerator and a denominator pair, then I'm fine. So 16 and 4, what can they both divide by? 4, yep, so I'll do 16 divided by 4 is 4. 4 divided by 4 is 1. And then the other pair, a few of you said the other pair divide by 5. Be careful. Yeah, good, Taylor. So they divide by 3, not 5. So divide by 3. That gives us 5 there, and that gives us 1 down there. So now we're going to multiply the new numbers by each other. So we'll do 4 times 5, and we'll do 1 times 1. And that will give us the answer. So 4 times 5 is 20. 1 times 1 is 1. So what is our simplified answer? Yeah, that would be 20. Simplified answer is 20. So if you're wondering, if you'd done 16 times 15 over 3 times 4, and then you'd simplified, you'd still get to 20. It just would have taken longer because you would have had to do the multiplication for those two. Okay, so our answer there is 20. Just wanted to answer a question that the student has asked based on number 4, in case a few of you were wondering the same thing at home. So someone's asked if we can just multiply the whole numbers and then multiply the fractions separately. We can't do that because you need to actually multiply 5 by 3 and multiply 5 by 3/4, which will give you a bigger number. So you do actually have to change them into improper fractions and then multiply. Okay, next question, number 5. We had a similar question last week. If you remember to put thirds in order, because we've got a recurring number, I would recommend just writing the first 2. So let's say, for the sake of example, that you had the recurring number 7777, goes on forever. Instead of writing that, if you're trying to compare it to some other decimals, just write it as 7, 7. Maybe 777 in that case. Yeah, I know if you rounded it, it would be 778, but just for the sake of ordering, it's probably safer to put it like that. So you're going to do the same thing with the 2/3. Just put the first couple of digits in that recurring number and then order them. So can you all give that a go for me, please? I'll just give you a couple of minutes to do that. Okay, I will pause again so you can pause at home and work out number 5 on your own and press play when you're ready for the explanation. Okay, so we're getting a mixture of answers for number 5, so finding it a little tricky. When you write these all as decimals, which is what I'd recommend here, then it's not too bad. So I'll just write 0.67 over here just so I have more room. 55%, to convert a percentage into a decimal, you just divide by 100. So divide 55 by 100 and you get 0.55. 3/5 is 0.6 as a decimal. Now, there are ways to convert that into a decimal. I won't go into those now, but if you didn't know what 3/5 was as a decimal, that would be a good one to learn. I'd say learn what the quarters are as decimals, so 1/4, 1/2, and 3/4, what the fifths are, and what tenths are as decimals, because it's useful just to know those. It will help you to speed up in exams. Okay, so 0.6, 7/10, 1/10 is 0.1, so 7/10 would be 0.7, and then finally 2/3. So 2/3, as I hinted at before, 2/3 is 0.6666, goes on forever. For the purposes of this question, I am going to write 0.66. One sec. I should have given myself some more room next to 0.6, so I'm just going to rub that out, because to order decimals, the easiest way to do it is add zeros so they're all the same length. So if I add a 0 to that, so now everything has 2 decimal points, so 2 numbers after the decimal point. Yeah, 2, 2, 2, 2, 2. And so we can kind of just ignore the 0 point and act like these are whole numbers. So we've got 67, 55, 60, 70, 66. So I'll put those in order, and make sure when you're doing this at home that you write the order that they're in before you answer. Don't try and order them in your head. There's just no point. It will only decrease your accuracy. So our smallest is 55, second smallest 60 or 0.6. Third, these are very close, but the third would be 0.66. So not rounding it has helped in that case. Fourth, 0.67, and fifth is 0.7. If you still weren't sure about the 66, you can look at it as, if that was 670 and that was 66, then it could also be looked at as 666 versus 670. So I can add a 0 to this because it was a finite number, it wasn't going on forever. And I can just add another 6 because I know the 6's go on forever. So our middle number there is 0.666, but we need to write the original number as our answer. The original number was 2/3. Okay, try and work out the next one for me. I'm not going to give you long for that. I may not even pause the video because there should be quite a quick way of doing it. Okay, I'm going to work out number 6 on the board. A few of you are getting that right, so that's great. So first of all, I'm going to do 3 times 32, because usually, remember, when we've got a number with zeros at the end, we ignore those and then can add them on to the end of our multiplication. So I'm going to pretend for now that my calculation was 3 times 3,200. I'll do 32 times 3, which is 96. And then I'll add the other 2 zeros. So I've got my answer to this. That's 9,600. However, our original calculation was 0.03 times 3,200. So I've ignored the decimal points. However, I can't do that forever. So I need to put them back in. I have 2 numbers behind the decimal point. So I put 2 numbers behind the decimal point in my answer, and that gives me 96. There's no need to write the zeros at the end of it, so our answer is just 96 after all that. Okay, write 0.84 as a fraction in its simplest form. Now, the 4 is in the hundredths column. So because the last digit is in the hundredths column, our fraction is over 100. So I take 84 put that over 100, and then simplify. Now, someone has already given me the simplified answer where they only simplified the numerator and they forgot to divide the denominator. So you have to be careful. Yeah, we just got the correction through. So if you divide both the numerator and the denominator by 4, you get 21. 100 divided by 4 is 25. Now just check that those numbers don't go any further. Make sure you haven't forgotten a factor. That's fine. So our answer is 21 over 25. Lots of right answers there. So well done, guys. Okay, number 8. Which sum has been set out correctly to give the answer 64? Best way to do it is just work out each one. But before we start that, you're going to need to use BODMAS or BIDMAS, some of you might call it. I think I'll use a new page for this. So BODMAS. Can someone tell me what the first letter stands for? Sorry, did I say 64 before? I mean 67. Yeah, so B is brackets. O, if you're using BODMAS, stands for of, as in to the power of. So if I write 3 and then I write that little 5, that means times 3 by itself 5 times, but we would read it as 3 to the power of 5. So if you have any numbers with like a little number up here, like a square, then you have to do that part first. In BIDMAS, that just stands for indices, which is the name of these little numbers as well. So it stands for the same thing, we're just calling it different things in each time. And then we've got DMAS, that just stands for division, multiplication, addition, subtraction. So you have to do division or multiplication before you do any addition or subtraction. So division, multiplication, addition, subtraction. So we need to remember BODMAS when calculating these questions. So in A, give me just a second to think about it. Okay, so BODMAS, I'll write it here. We've got addition, multiplication, and subtraction in A, so we need to start with the multiplication, and that would be 24. So now we've effectively got 8 plus 24 minus 5. Now we're going to just start at the beginning because we've got addition and subtraction. So we'll do 8 plus 24, which is 32, take away 5, and we get 27. So A is not going to work. I'll put a line through it so I remember. Okay, the next one, remember B comes first. So you'll work out what's in the brackets and then you'll multiply them. Just give you a second. Can you tell me what answer you get for that? Yeah, good. So 8 plus 4 is 12. 6 minus 5 is 1. So 12 times 1, your answer is 12. So that one doesn't work either. Hopefully C works, or we'd have to go back and see what we did wrong. So 8 plus 4, because we're doing the brackets first, is 12. Then we do the multiplication before we do the subtraction. So we do 12 times 6, which is 72. And then you subtract 5, so 72, subtract 5, and that gives us 67. It's C, yes. Just seeing the answers and declaring it's C. Exactly, it's C, it works. So just remember BODMAS in future if you've got lots of different operations. Okay, so add together the 3 lengths, 1.4 meters, 33 centimeters, and 508 millimeters. Now, when we did a similar question a few weeks ago, this was probably one of the most incorrectly answered questions. So take your time, make sure your conversions are right, and put them all in the same units of measurement before you do any addition. So just work that out quickly. I'll just write them on the board so I'm maybe a step behind you. So 1.4 meters, 140 centimeters, 33 centimeters just stays the same, and 580 millimeters would be 58 centimeters. So you're just adding those three numbers. Remember, there are 10 meters in a centimeter. Good. So we've got a little inaccuracy. Check that your figures are the same as mine when you're adding them up. Remember, everyone, that 10 millimeters make a centimeter. Millimeters are those teensy-weensy little divisions on your ruler. So you have the centimeters, the main divisions, and then the millimeters are the little ones that break those up. So 10 millimeters in a centimeter. Okay, yep. All right. And still, I think some of you were not doing that properly. So match up your measurements to the ones that I wrote on the board, because the answer is definitely not 10.5. The answer that we get when we add these is 231 centimeters. And then just remember to check that you were working your answer out in the right units of measurement, because this could ask for meters and then you couldn't put 231. So that says centimeters, so we're fine. No conversion needed, just 231. Okay, work out 30% of £16.80. I'll work it out on the board. You can pause at home if you don't want to see the explanation, or you can just ignore it until you've worked it out. I'm going to find 10% of the number rather than 1%, because 10% goes into 30. So 10%, I go from 100% to 10%, let's divide by 10. If I do that on the other side, divide by 10. So 10% of £16.80, we just move the decimal point one place backwards, that's 1.68. And then 30%, we do times 3. Now I've got some answers here that have the right digits, but like 50.4, check whether that seems sensible. So 30% of £16.80. So we know we're going to get a number that is less than half of this. So it's going to be less than £8, because half of 16 is £8. So if you're getting something like 50.4, you know that's too big, and so you need to look at your answer again. So yes, I think most of you got it. £1.68 times 3 gives us £5.04. Now I would just have a quick read of the question again, because sometimes these percentages questions say something like reduce by 30% or increase by 30%. So I'm going to reread the question to make sure I don't need to do anything else. 30%, so work out, I should start from the beginning, work out 30% of £16.80, and that's £5.04. So we're fine, we've done everything we need to do, we can give our answer. Okay, next page. Then I find it. There we go. Okay, averages. So when a question says the average of some numbers, remember average means mean. So if it just says average, they're talking about finding the mean, and we find the mean by adding the numbers together and dividing by the number of numbers that you have. So take a look at this, at number 11, see how far you get. I'm going to pause before giving the explanation. All right, let's go through the method for number 11. So the average weight of 5 parcels is 3.7 kilograms. So that means when you added up the weight of the 5 parcels, you divided by 5, because there were 5 numbers, you got 3.7. So I'm going to write a little missing number calculation here. We added them up, we divided by 5, and this is not showing on my screen. Let me try again. There we go. So we add them up, we divide by 5, and we got 3.7 kilograms. This question, now make sure you read this properly because it's a little different to some of the ones that you might have done before. So 4 of the parcels are identical and each weigh 3.5 kilograms. So note that's not the average, although it would actually be the average of those 4, but they're telling us that each one weighs 3.5 kilograms. So if you haven't already, I need you to tell me how much those 4 parcels weigh altogether. Each one weighs 3.5 kilograms. How much do the 4 weigh altogether? Yep, because you're timesing by 4, you could double and double again. Double 3.5 is 7, double 7 is 14. So 3.5 times 4 is 14 kilograms. So 4 of the parcels weigh 14 kilograms altogether. Now use this mean calculation to figure out what the 5 parcels weigh. So you're going to fill in this first box by working backwards. So you'll do 3.7 times 5, and that will give you the weight of all 5 parcels. Can you do that for me, please? If you found it earlier because you'd got it right, you can just tell me the answer. That's fine, you don't have to work it out right now. So what do the 5 parcels add up to? 3.7 times 5. Not getting any answers yet? I'll just tell you for the sake of speed. So when you multiply those together, we get 18.5 kilograms. Okay. So originally the parcels added up to this. When you take off the 5th parcel, they add up to 14. So if we find the difference between 18.5 and 14, then we'll have the weight of the 5th parcel. 18.5 take away 14 is 4.5, good. Okay, next question. Have a little think for me about how to do this. We're going to use a method that we haven't actually used before in these sessions. So at a birthday party, 12 children said they liked orange juice and 10 children said they liked lemonade. If 7 of these children said they liked both and 3 others said they only liked water, how many children were at the party? What method am I going to use? I don't want to know the answer, I just want to know what method you think I should use to work this out. Can't use ratio. We can use ratio when something is double something else or 3 times, but we don't have that. Writing it down, I do need to write it down, but that doesn't help me. A table, Olivia, interesting. Table's not the best and easiest method, but you're getting closer. Nope, not the age difference method, not a bar chart. Venn diagram is what is best for us to use for this, because we have children that say they like one thing, and then we have some that say they like both, and some that say they're separate. So a Venn diagram, making our own with this information, is going to be the quickest and easiest way of doing it. Well, sorry about my circles, but if this was an exam, it wouldn't matter. So let's just pretend it is. So make sure you label them. That's orange juice, that's lemonade, and then water down here. So why don't you take a second on paper? I won't pause the recording, but take a second on paper to try and fill in your Venn diagram, and then I'll show you what it should look like on the board. Okay, let's talk about it. The first thing I'm going to put in actually is 7 of these children said they liked both. The reason I'm doing that is because I don't want to write the wrong number in here and then realize that it needs to be split between the different sections. So 7 of these children said they liked both, and by both they mean orange juice and lemonade, because those were mentioned in the previous sentence. So 7 goes here in the intersection between orange juice and lemonade. Now it says 12 said they liked orange juice. And then of that 12, 7 liked lemonade. So how many orange juice, like pure orange juice, children are left once you take away that 7? 5, good. So now I have 12 children in total that like orange juice, but I've got the 7 that like lemonade as well. So same thing with lemonade. It says 10 children said they like lemonade, but we've already got 7 that like both. So how many children just like lemonade? Good, Olivia, 3. Shri, you're jumping ahead and that answer is way too big, so concentrate for me. Okay, so we've got 10 that like lemonade now. And then it's simple. So then 3 others said they only liked water, so I'll put a 3 in here. Now to figure out how many children there are, all I do is add up the numbers in this Venn diagram. Look for bonds to 10, 7, 3, make 10, 5 and 3, make 8. So altogether I have, 18 children at this party. 18 is our answer there. Okay, let's have a read of the next one. Aidan was told to divide a certain number by 17. Instead, he divided the number by 7 and got the answer 68. What was the answer to the division he was supposed to do? Might want to read that again, just to get your head around all the information. So Aidan was told to divide a certain number by 17. Instead, he divided by 7 and got the answer 68. Let's draw the whole missing number. Sentence again. Mute, please. Divide by 7 and got the answer 68. So use that to figure out what the original number was. But remember, that is not our last step. So can you work out the original number? Original number. Just had an extra 0 on there, Olivia, that you didn't need. Yep. So 68 times 7 should give you 476. If you hadn't got that quite yet, it's okay, but perhaps do some multiplication practice so that you can get really quick at multiplying, because that will save you a lot of time in an exam. So the original number was 476, and he was told to divide that number by 17. And they want to know what answer he was supposed to get. So you'll need to do 476 divided by 17. I'll do it on paper for you. 476 divided by 17. That's the calculation he was supposed to do. So 17's into 4, 0. Now make sure you write the 0 there, by the way, even though it doesn't go in. Still write the 0 because it stops your numbers from getting like skew-if and in the wrong columns. So we carry the 4 to the 7. 17's into 47. Now we should know double 17, that's 34. So that will go in twice. 17 times 3, just in case you weren't sure, that's 51. So it's too big. So what is the difference between 47 and 34? Can anyone tell me? What am I carrying? Yep, 13. So now I need to know how many 17s are in 136. Now remember, again, we don't know the 17 times table, presumably. So let's use what we do know. 17 times 10 is 170. Now, that's a bit bigger than this. So maybe try working out 17 times 8 and seeing if that is less than or equal to 136. So 17 times 8. Oh, look what we get. 17 times 8 is 136 exactly. So how many 17s go into 136? 8. That's your answer, 28. Okay. A piece of string is 160 centimeters long. It has formed into a rectangle whose length is 3 times its width. Work out the area of the rectangle in square centimeters. Now, can anyone give me the method that we should use for this? It's one of the methods that you mentioned before. Yes, Olivia. So, yeah, ratio. So we're going to use ratio for this because we've got length is 3 times the width. So in our ratio will be 3 to 1. Nice and easy. First row sorted. However, we do need to be careful because it says the piece of string is 160 centimeters long and it's formed into a rectangle. So basically the perimeter is 160 centimeters. But that means that when you add 2 lots of the length and 2 lots of the width, you get 160. So yes, you do need to halve 160. I'll show you why. So in ratio, we'd have length to width, 3 to 1, like we said. But you see how this is just one length and one width that we have. So I need just one length and one width from this rectangle, which will be half of 160. So half of 160 is 80. In my ratio, I've got 3 to 1. So the first row adds up to 4. However, I know in this question, the length and the width add up to 80. So I put that on the next row. Then it's just a matter of going from 4 to 80. So 4 times 20 is 80. So you need to multiply both numbers on that first row by 20. So what's the length and what's the width? Just quickly. Yep, so length is 60, width is 20. Now, can I put those down as my answer? No, I cannot. Good. So don't get complacent just because you found some numbers. Can't just put them down as your answer. We reread the question to make sure we've answered it correctly. So work out the area of the rectangle in square centimeters. So you're going to need to multiply those two numbers. Don't do it in a rush because I'm getting some wrong answers. So 20 and 60. 6 times 2 is 12. Add the 2 zeros at the end and you get 1,200 centimeters squared. By the way, if you had, say, forgotten to halve 160, what would be a good idea when you get the length and the width is to check your answer by actually adding those up to see if you get 160. Because if you hadn't done it properly, you wouldn't get the right perimeter when you added them up. Okay. Number 15. This is hard. If someone comes up with a method for this, I'll be very impressed, but I'll show you how to do it regardless. So, in the following diagram, the two shaded rectangles have equal areas. What is the total shaded area? So you can see here we've got the widths of the rectangles, we've got the total length, but we don't know what these lengths are. So I'll give you a few seconds to think. Keep recording while you think at home and here. Someone perhaps come up with the method for me, even if you don't do the calculation on your own. It is confusing, so reread the question, have a look at that diagram, see if anything comes to you. Adding the 4 and the 3 won't help because all we'll get is a way of finding the area of the whole thing, and that doesn't help. So Emily, you said the whites are the same areas. Unfortunately, they're not, because if you actually just take a look, because this is 3 and this is 4, these bits aren't the same, so we can't use that to help us. It's not 49, I'm not sure. You're close, but that's not where it comes from. Length and width divided by 2. No. Okay, what we're going to do with this is use algebra. Okay. So, if I called this distance here W, If I knew what W was, how would I work out this distance, this length? If I knew what W was, how would I work out this? Yeah, good. So that would just be 14 minus W. That's how we'd figure it out. So if I wanted to find the area of this, and the length is 14 minus W, how would I find the area of just this black rectangle? I would multiply this side by this side. So that's what I'm going to do. I'm going to do 3 times 14 minus W. I'm going to put it in brackets. So just to go over that, because I think a couple of you are still confused. So let's just call this width. I probably should have called it L actually, but it doesn't really matter what the letter is. So if we call this W, if we then wanted to work out this, if they were both numbers, we would just do 14, take away this amount. If this was 5, you'd do 14, take away 5, and you'd get this. And then if we had numbers and we wanted to figure out the area, we'd do whatever this length is times 3. So that's what I'm going to do, but just with letters. I'm going to do it algebraically. So I'll do 14 minus W times by 3. And then how would I work out the area of this rectangle? Don't jump ahead because I'm still getting wrong answers and I don't want you to miss anything. So how would I work out the area of this rectangle if I'm calling this W? I would do 4 times W, also known as 4W. So the area of this one is 4W. Now the question tells us they have equal areas. So if this is the area of one and this is the area of the other, they must equal each other. So we get 3, open brackets, 14 minus W equals 4W. Now we have to multiply out these brackets, so on the left. So we do 3 times 14 and we do 3 times minus W. 3 times 14, I happen to know, is 42. 3 times minus W is minus 3W equals 4W. Now I've got an equation that I can solve and I can figure out what W is, and then I can go from there. Then it will be pretty easy. So can you just try and solve that equation to figure out W, please? Send answers privately for me. So in case anyone's not sure, I'd solve by doing add 3W, add 3W. Now this is tricky, by the way, if you haven't done algebra before, so it may be difficult for that purpose. Okay, so 4W add 3W is 7W. That's got rid of this, and so I've just got 42 on that side. So 42 equals 7W. So what does that mean W is? Yep, getting some right answers. So W must be 6. 7 times W is 42. 7 times 6 is 42. So W must be 6. Right, so let's look at the original diagram. Now we know that W is 6. We know that this is 6. And then what is this length? Remember we said that would be 14 take away W. And we know what W is now, so what's that length? Good, 8. And now we can find the areas. Now note the question says the total shaded area. I would work out the area of both of these quickly just to make sure they are equal, but don't forget you have to add those to find your final answer. So 3 times 8 is 24. 6 times 4 is 24. Add those together and you get 48. So that is the total area of the shaded sections? No, that was really tricky. And if you haven't done lots of algebra, it's even harder. So some of you will just practice some more algebra soon. Okay, number 16. Now this is similar to the ones that we've done each week. They always seem to have a question like this in the Manchester exam. So Nancy bought 5 oranges and 2 apples and they cost £3.40. At the same shop, David bought 3 oranges and 1 apple and paid £2. What would Steve have paid if he bought 4 oranges and 2 apples from this shop? So remember, first thing we need to do is write out equations to represent that information. Why don't you jot those down for me? Same question, just so we have some more room. Remember, guys, the chat is for sending answers only. Okay, so 5 oranges and 2 apples cost £3.40. 5 oranges and 2 apples cost £3.40. David bought 3 oranges and 1 apple and paid £2. 3 oranges and 1 apple and paid £2. I'm going to actually delete that pound sign. So I'm only going to add to the confusion right now. So what would Steve have paid if he bought 4 oranges and 2 apples? So basically, I need the price of an orange and an apple so I can do the rest of it. Okay. Remember, we can't solve these equations when we only have, there's a trick way of doing this that I've just realized. So usually I would say we can't solve these unless we've got the same number of apples and the same number of oranges. So we'd have to multiply one of the equations. But they've actually made this easier than it normally is because it's got 4 oranges and 2 apples. So if I can get to an equation where I have 2 oranges and 1 apple, I would be able to double that to find the answer. Have a look and see if you can find the shortcut for me. What if I just subtract the equations? If I subtract one from the other, what would I get? And to type it out for me, you can jot it down at home. I'll subtract the prices, so that would be £1.40. What about the rest of it? Just think about actually subtracting in person. So if I had 5 oranges and 2 apples, and then I subtract 3 oranges and 1 apple, what am I left with? Not just £1.40, but what have I got on the left? Yeah, 5 oranges take away 3 oranges, 2 oranges, 2 apples take away 1 apple, 1 apple is left. So I know 2 oranges and 1 apple equal £1.40. The question wants to know how much 4 oranges and 2 apples cost. So how much do they cost? Yep. Okay, we're getting a range of answers. I have had a correct answer, another one. Remember, 4 oranges and 2 apples. I've got twice the number of oranges, twice the number of apples, so it will cost twice the amount. Well done to those of you that have sent me the correct answer. Cost twice the amount, so it's just £2.80. So it saved us having to find the cost of an orange and an apple individually in this case. £2.80. There we go. Let's go back. Okay, now 17. I don't say this often, but trial and error is actually going to be probably the easiest way of working this out. I would also recommend drawing a little diagram if you think it would help you. That's what I did just to get all the information straight in my mind. So St. St. Hugh's School Hall is in the shape of a large box or cuboid. The area of the floor is 200 meters squared. The area of one of the side walls, is 150 meters squared, and the area of an end wall is 48 meters squared. What is the height in meters of the hall? Let's draw a cuboid. Oh, sorry. Ooh. There we go. Sorry about that. Pressed the wrong button. Okay. So the floor is 200 meters squared. One of the side walls is 150 meters squared. And one of the end walls is 48 meters squared. And we need the height, which is this, or one of the others, depending on which one you look at. Okay. So to find the area of each side, you multiply the height by the length or the width. So you do this times this to find 48. Now there are lots of different numbers that could make, that could multiply to make 200 or 150. There aren't so many whole numbers that you could multiply to make 48. So let's try a couple out and see. So can you give me a pair of numbers that multiplies to make 48, please? Okay, 6 and 8, 24 and 2, and 12 and 4. I'm not going to go with 24 and 2, only because I think it's unlikely that in a school hall you'd have like 12 centimeters, 12 meters across and then only 2 meters up, and vice versa. You wouldn't have like 2 meters across and then 24 meters up, because that would be a really, really high roof. So let's try 6 and 8. So let's say the bottom is 8 meters and the side is 6 meters. Sorry, I wrote 60. I mean 6. So what times 6 would give you 150? I want to work out this measurement. So what times 6 gives 150? Work it out on paper, because I've got a wrong answer. Please use the private chat. I'm going to have to ignore any answers that come to everyone now. Yeah, good. So 25 meters. Okay. So which numbers would we multiply, theoretically, to find the floor space? If our measurements are right, what would we multiply to find the floor space? Look at the diagram to help you. Someone said it's gone. You can still see it on the screen, right? Okay. So to find the floor space, if this is 8 and this is 25, then we would do 8 times 25 to find the area of the floor. So just quickly work out 8 times 25 for me. It is not 20. It's way too small. Yeah. So 8 times 25 is 200. That means everything works in that case, because 8 times 6 is 48, 6 times 25 is 150, and 8 times 25 is 200. So all of those measurements work, which means we're ready to answer the question. So what is the height in meters of the hall? It's just this measurement here. So it's 6. Okay. We are on the home stretch, just the last few questions. Okay, a number is pro-added. They've made this thing up, if you're wondering. If I multiply the number by itself and then add the original number to that answer. So for example, pro add 8, you do 8 times 8, multiplying it by itself is 64, and then you add the original number, and then you would get 72. So what number gives the answer 210 when it is pro added? Now make sure you don't pro add 210. We want to know what number gives 210 when it's pro added. So again, trial and error is going to be the only way that we can do this, really. So you need a good knowledge of square numbers, because remember, when you multiply a number by itself, you're just finding the square of that number. I always recommend memorizing the square numbers up to 12 squared. And it doesn't hurt to remember the square of 15, which I believe is 225. Yes, it is. So square of 15 is 225. What's the square of 12? 144. Now, if we pro add 12, just 12, then that's not going to be near 210, because you'd have to add 12 to that, and we know that's not 210. 15 squared, sorry, is 225, so that's too big. So why don't you try one down from that, try 14 squared, and see if that works, because it's going to be somewhere between 12 squared and 15 squared, based on what we know already. So just try 14 squared, and then add 14, see if you get 210. And pause the video quickly in case you're still working it out at home. Okay, so if you're not sure about the pro added part, you may just need to reread the question. Some of these, they're complicated, so just reread until you get it. So, or if it's taking too long to get it in an exam, then do just skip. So pro added, it says that means multiply the number by itself and then add the original number to that answer. I think my screen's frozen. So if you pro added 14, you would do 14 times itself, so 14 times 14, and then add the original number, 14, to see if you got the right answer. So 14 times 14 is, I've got my notes, is 196. So to pro add, we've done the first part, and then you would add 14 to pro add it. Add 14 gives you 210, so our answer is 14. So what number gives the answer 210 when it is pro added? The answer is 14. Okay, number 19. This is another one, as we often get in these exams, where you need to have a quick think about the best way to go about this. And I think I say this every week, but in case you've forgotten, the best thing to do, if this is taking you a while and you can't figure out a quick way of doing it, is go back, make sure you've got the answers to the other questions, do the simpler ones, and then come back to this if you have time. Okay? In this particular exam, every question is worth 1 mark. So doing a hard question doesn't get you any more marks than doing an easy question. So you might as well just do as many easy ones as you can. Okay, let's have a look. How many whole numbers less than 100 cannot be divided exactly by 4 or by 5? I'll give you a few seconds to have a think about how you might be able to approach this. It might help to imagine your times tables. Okay, so Olivia's saying, take away all the digits ending with 5 or 0 first. Yes. Now, how can we quickly figure out all of those numbers, apart from just counting in 5s, which won't take too long, but it's going, once you start counting in 4s, that's going to take longer, and so I want to avoid that. If you think about your times tables, now what times 5 equals 100? So what times 5 equals 100? 20. So if you had the times tables written out, you'd have 0 times 5 is 0, 1 times 5 is 5, 2 times 5 is 10, and then you could go on until you got 20 times 5 is 100. Okay, so not including this last one, because we wanted numbers less than 10, how many of these numbers are you going to have? How many numbers can you multiply by 5 to get a number less than 100? Yeah, so you'll have 20 numbers on this side, yeah, including the 0. And then these numbers, so you must have 20 numbers on this side that are less than 100. So numbers that, multiples of 5 equals 20. Now, can you do the same thing for the multiples of 4? Same method, and think about how many of those multiples you will have. It's not 45. I can see why you said that, Olivia. Hold on, and I'll explain why not. Okay, yeah. So a few of you have got it there. So multiples of 4. 4 goes into 125 times. So there will be 25 multiples of 4, including 0 times 4. So 20 and 25 does equal 45, but I have just said that's not the answer. So that's not how many numbers that you have up to 100 that divide by 4 or 5. Why is that not the right total? Okay, Shri, you've said 40. Why did you say 40? Okay, so Shri had suggested it was 40. That, I'm assuming, is because of the duplicates. Or it should be anyway. So in both of the times tables, we'd have had the number 0. What other duplicates would we have had in both the 4s and the 5s? We'd have had 20. So any multiples of 20 basically would have been in both the 4 and the 5 columns. So 20, 40, 60, and 80. Those 5 numbers would be double counted. So if I take those off, I take that off 45 and I get 40 numbers that 4 and 5 go into. Now, let's go back to the question and reread what they wanted. So how many whole numbers less than 100 cannot be divided exactly by 4 or by 5? So we found how many numbers can. We said that was 40. So what's our final answer? 60. Good. All right. And finally, 20. So 2 crosses can be put in 3 squares in 3 different ways as follows. So there's your combinations. In how many different ways can you put 3 crosses in 5 squares? The only way you're going to be able to do this is plotting them out on paper. Let's do it together quickly. You can make a start. So try and do it systematically. So don't jump systems each time. So I'm going to put 1, 2, 3, 4, 5 as my columns. And then let's start. So the simplest way is x, x, x. I'm not going to write in the zeros because it just takes up more time. And then let's move those 3 across. So 3 there, and then let's move them across again. So now I know I've covered all of the combinations where we have the 3 crosses together. Now you'll try a slightly different combination. Can't move these up nicely. sorry. So let's try maybe 2 together and 1 separate. So if I put that one there, and then 2 together, and that one over there. Now let's do, what's the most natural progression from this? Let's see. Okay, so let's do 1 together and 2 over here. 1 there, and then 2 over here. Then what other combinations can I have? Do you want to type in the chat? You can use X's and zeros to show me what other combinations are possible that I haven't got already. I've already got ones with the 3 crosses together because we did those ones first. What if I have, what if I have 2 in the middle, kind of, and 1 on this side? And what if I do the reverse of that? I don't have room here. So if I do 1, 2, 3, 4, 5. Doing this on 2 different pages is not ideal, by the way. In an exam, then you would make sure that you have enough space to do the whole thing. So I'm just going to move this one over here for my next question. And have we done the reverse of that? Yes, we have. So we've done 2 crosses over here and 1 over here, and now I've done 2 crosses over here and 1 over here. Now I think there's just one more combination that we haven't done. Yes, one more combination. Emily, if you reverse what you did before, then that works. You've got 3 O's there, whereas I need 3 crosses. What's the last combination that I need to do? Nearly. I haven't done that one. Okay. So someone's given me an explanation for this, but I'm afraid it doesn't work. You do actually just have to do it the long way. You're trying to relate the number of crosses to the number of combinations, but it's not going to work that way, I don't think. So we have how many combinations? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So once, if you had those all on the same page, I would have a look through, make sure you haven't duplicated any, make sure you haven't left any out, and then our final answer is 10. Okay. That is the end of the paper. I'm going to stop my recording. Bye for those at home.
Well done for challenging yourself and making it all the way to the end of this video. If you're on a roll with maths today, then check out one of our other Maths 11 Plus videos by clicking on the right. Or if you want to switch to English, check out our vocabulary videos by clicking on the left. We'll upload more videos soon, so don't forget to click subscribe so you're notified as soon as they come in. See you next time.